let's go to LeetCode 422. Max XOR of two numbers in an array. And for this question, it gives us an integer array and let us to find the max XOR with the two numbers, which is in the array. For example, example 1, we'll see 5 XOR 28, 5. It has a maximal number that is 28. So for this question, we can think about for every number, it can convert to a binary char sequence, right? Character sequence. So for example, we have so for the integer, we know the length is smaller than 22, right? So it will be the maximal will be 21, 31. Sorry. So what I was thinking about is that we convert for every number we use a length 31 binary string, right? And we know for every character for this number or every character in the sequence, it can be either 0 or 1, right? So what I was thinking about is that we can create like a tree node, right? Or we call tri node, and it can have a for every node it have two child, right? One will be goes to 0 and another will go to 1, right? So we insert this number based on its binary string. If it is, for example, it is 0, then it go to this path. If another 0, it go to this path. If it is 1, go to this path, right? So after we insert, this will be pretty much like a tree structure, or it is also like we call tri, right? Structure. So for every number, after we insert all the numbers, right? So then we iterate, iterate every number. For example, we have number 1, right? Number 1, for this number 1, in the child path, it may, for example, it go to this kind of path, right? And we know the length is 31. And what we want is that in order to get a max XOR, that is that for every node, right, we're trying to see go to its reverse, right? We're trying to go to its for example, this is 1, then we are going to go to 0, right? So for every node, we're trying to go to its XOR node. If the XOR node does not exist, then we just go to this node itself, right? Because it's possible in this kind of length in the future we have some other number will be different. So we are trying to find a number, a path which has more different digits in its path, and also we want to get on the top, right? On top to be max as higher priority. So we'll see if this is 0, we find a 1, right? We go to this path, and for this one, we didn't find. It's better we find a 0, right? But we didn't find the 0 here, so we have to go to the 1 path because in the below path it may have some kind of differences. Then, for example, this is 1, right? Then we go to this 0 path until we find a path which have more digits differences, right? So that will be our result. So based on this kind of concept, we begin to write code. So we write a class called child node. And for this child node, we are going to have an array called children. And for this this node, right? This array, it only have for its children can only be 0 or be 1, right? So we just have the size, the array size to be 2. So what we're going to do is that we possibly have a child root, right? No, root equals new no. And we need to have our insert function. So what we do is that we have a child node current equals root, right? So what we're going to do is that int I equals 31, I greater equal to 0, right? I plus plus. And let's look at so we convert this number to digit sequence, right? So from the higher from left to higher digits to the lower. So we are get current bit equals num redshift I and 1, right? Trying to see whether it is in 1, right? So that means this is it's digits whether this is 1 or not. So let's say like a child if parent dot children bit equals to none, right? Then we create a new one, parent dot children bit equals new child node. And then we move to the next parent equals parent children. Bit. So this will be the insert function. And for the and also we need to write our find max. It int find max, right? So we also have a num here. We also need to have a child node current equals to root. So we also do for int I equals 31, right? I greater equals to 0, I minus minus. So we also look at this numbers bit, right? This numbers bit is in bit equals this number right shift I and 1, right? So this is a single side of 1. So we'll say if we're trying to see it's XOR, this bit XOR 1, whether its child exists or not, right? So if children parent dot children bit XOR 1 doesn't equal to none, right? Then we go to we can have this bit because we to XOR 1, right? Because we don't use it this we don't use this bit anymore for the next position. We can use bit XOR equals 1, right? And because now the two nodes has differences, right? So we can have a int sum equals to 0, right? We need to add these bits to this sum, right? So we'll have sum to add to where it is result, right? Use all, right? Add to these digits, we use all equal to so this is the ith digit, right? So we should have one shift left shift I, okay? And then for our current equals current of children bit, right? So if a bit XOR XOR 1, right, exists, then we have bit to be its XOR value. Otherwise, we just go to a bit value. In the end, just return result. So this is find max. And after doing this kind of function, we just need to we need to write our main, right? So for every number in nums, we should insert now. And after insert, we'll have the maximal XOR. So so that is for every number it's XOR, right? And then now we want to find every the global value maximum, right? Maximum equals, for example, we have this one as 0, right? So let's say for int num and nums. So we just update the global one equals max find max and max, right? Yeah, in the end we just return max. Which equals insert bit equals current equals to root. Current equals this one. This minus, so this is minus, okay? So if there are n numbers, this insert will be 31 multiplied by n. So it's just the all in operation, right? So the find is also all in, right? 31 multiplied by n.